what is Venus's orbit like? Venus takes 243 Earth days to rotate on its axis, which is by far the slowest of any of the major planets. In fact, its day is longer than its year, and that may be due to the thick atmosphere of Venus serving as a big brake on the planet's rotation. And because of this sluggish spin, its metal core cannot generate a magnetic field similar to Earth's. The magnetic field of Venus is 0.000015 times that of Earth's magnetic field. If viewed from above, Venus rotates on its axis in a direction that's the opposite of most planets. That means on Venus, the sun would appear to rise in the west and set in the east. On Earth, the sun appears to rise in the east and set in the west. The Venusian year, the time it takes to orbit the sun, is about 225 Earth days long. Normally, that would mean that days on Venus would be longer than years. However, because of Venus's curious retrograde rotation, the time from one sunrise to the next is only about 117 Earth days long. The last time we saw Venus transit in front of the sun was in 2012. And the next time will be in 2117. Venus's atmosphere. The very top layer of Venus's clouds zips around the planet every 4 Earth days, propelled by hurricane-force winds traveling roughly 224 miles per hour, 360 kilometers per hour. This super-rotation of the planet's atmosphere, some 60 times faster than Venus itself rotates, might be one of Venus's biggest mysteries. The clouds also carry signs of meteorological events known as gravity waves, caused when winds blow over geological features, causing rises and falls in the layers of air. The winds at the planet's surface are much slower, estimated to be just a few miles per hour. Unusual stripes in the upper clouds of Venus are dubbed blue absorbers or ultraviolet absorbers because they strongly absorb light in the blue and ultraviolet wavelengths. These are soaking up a huge amount of energy, nearly half of the total solar energy the planet absorbs. As such, they seem to play a major role in keeping Venus as hellish as it is. Their exact composition remains uncertain. Some scientists suggest it could even be life, although many things would need to be ruled out before that conclusion is accepted. The Venus Express spacecraft, a European Space Agency mission that operated between 2005 and 2014, found evidence of lightning on the planet, which formed within clouds of sulfuric acid, unlike Earth's lightning, which forms in clouds of water. Venus's lightning is unique in the solar system. It is of particular interest to scientists because it's possible that electrical discharges from lightning could help form the molecules needed to jumpstart life, which is what some scientists believe happened on Earth. Exploring Venus. The United States, Soviet Union, European Space Agency, and Japan Aerospace Exploration Agency have deployed many spacecraft to Venus, more than 20 so far. NASA's Mariner 2 came within 21,600 miles, 34,760 kilometers of Venus in 1962, making it the first planet to be observed by a passing spacecraft. The Soviet Union's Venera 7 was the first spacecraft to land on another planet, having landed on Venus in December 1970. Venera 9 returned the first photographs of the Venusian surface. The first Venusian orbiter, NASA's Magellan, generated maps of 98% of the planet's surface, showing features as small as 330 feet, 100 meters, across. The European Space Agency's Venus Express spent 8 years in orbit around Venus with a large variety of instruments and confirmed the presence of lightning there. In August 2014, As the satellite began wrapping up its mission, controllers engaged in a month-long maneuver that plunged the spacecraft into the outer layers of the planet's atmosphere. Venus Express survived the daring journey, then moved into a higher orbit, where it spent several months. By December 2014, the spacecraft ran out of propellant and eventually burned up in Venus's atmosphere. Japan's Akatsuki mission launched to Venus in 2010, but the spacecraft's main engine died during a pivotal orbit insertion burn, sending the craft hurtling into space. Using smaller thrusters, the Japanese team successfully performed a burn to correct the spacecraft's course. A subsequent burn in November 2015 put Akatsuki into orbit around the planet. In 2017, Akatsuki spotted another huge gravity wave in Venus's atmosphere. The spacecraft still orbits Venus to this day, studying the planet's weather patterns and searching for active volcanoes. As of at least late 2019, NASA and the Russian Academy of Sciences Space Research Institute have discussed collaborating on the Venera D mission, which would include an orbiter, a lander, and perhaps a solar-powered airship. We're at the pen and paper stage where we're considering what science questions we want this mission to answer, and what components of a mission would best answer those questions. Tracy Gregg, a planetary geologist at the University at Buffalo, told Space.com in 2018. The earliest possible launch date we'd be looking at is 2026, and who knows if we could meet that. NASA has more recently funded several extremely early-stage mission concepts that could look at Venus in the coming decades, under the NASA Innovative Advanced Concepts program. This includes a steampunk rover that would use old-school levers instead of electronics, which would fry in Venus's atmosphere, and a balloon that would check out Venus from low altitudes. Separately, some NASA researchers have been investigating the possibility of using airships to explore the more temperate regions of Venus's atmosphere. In 2021, NASA announced 2 new missions to Venus that will launch by 2030. The agency announced on June 2, 2021, that they will be sending missions DaVinci and Veritas, chosen from a shortlist of 4 spacecraft, for the next round of discovery missions to Venus. DaVinci, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, will dive through the planet's atmosphere, studying how it changes over time. Veritas, Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy, will map the planet's surface from its orbit using radar. On June 12, 2021, ESA announced its next Venus orbiter, Envision. A new era in the exploration of our closest yet wildly different solar system neighbor awaits us, Gunther Hasinger, ESA's Director of Science, said in a statement. Together with the newly announced NASA-led Venus missions, we will have an extremely comprehensive science program at this enigmatic planet well into the next decade. ESA hopes to launch the mission to Venus in the early 2030s. Private space explorers are also eyeing Venus. Rocket Lab announced in 2020 that it plans to ferry a spacecraft to Venus to deploy a probe within the atmosphere. The spacecraft, according to a 2022 paper, has a 2-pound, 1-kilogram instrument on board and is designed to survive 5 minutes in the clouds of Venus in a more temperate, Earth-like zone roughly 30 to 37 miles, 48 to 60 kilometers above the surface. It's all part of a greater search for life on Venus, which got a kickstart that year from an intriguing new study. Step 6. Is there life on Venus? While destinations in our solar system, like the moons Enceladus or Titan, or even planet Mars, are currently the go-to spots to search for signs of extraterrestrial life, but a breakthrough scientific discovery in 2020 suddenly had scientists discussing whether or not it was possible that life could somehow exist in the present-day hellish atmospheres of Venus. Now, scientists think that it is most likely that, billions of years ago, Venus could have been habitable and fairly similar to current-day Earth. But since then, it has undergone a drastic greenhouse effect that has resulted in Venus's current iteration with scorching surface temperatures and an atmosphere that many describe as hellish. However, in 2020, scientists revealed the discovery of a strange chemical in the planet's clouds that some think could be a sign of life: phosphine. Phosphine is a chemical compound that has been seen on Earth as well as on Jupiter and Saturn. Scientists think that, on Venus, it could appear as it does on Earth for very short amounts of time in the planet's atmosphere. But what does this phosphine discovery have to do with the search for life? Well, while phosphine exists in strange ways such as rat poison, it has also been spotted alongside groups of certain microorganisms, and some scientists think that, on Earth, the compound is produced by microbes as they decay chemically. This has caused some to suspect that, if microbes could create phosphine, then perhaps microbes might be responsible for the phosphine in Venus's atmosphere. Since the discovery, there have been follow-up analyses that have made some doubt whether or not the compound is created by microbes, but scientists are continuing to investigate, especially with new missions planned for the planet. Further, scientists searched for evidence of microbe waste, or poop, in a 2022 study and found no evidence of any activity. There were no spectral fingerprints suggesting active life within the atmosphere, which makes the premise of life hard to prove absent more compelling evidence, the author said.
Step 7.
Terraforming Venus. Science fiction is replete with scenarios where astronauts terraform a planet to make it more Earth-like. How this could happen, and whether it is feasible, are matters of tremendous uncertainty. Most often, scientists and science fiction fans talk about terraforming Mars because the red planet is a little more habitable to humans than Venus, what with the lack of massive active eruptions as a start. Terraforming any planet is sure to bring up ethical questions about how to protect any life that might be there, along with how to preserve any information that life left behind. Venus is not hospitable to life as we know it, but one can never be too sure. Assuming we do want to go ahead with terraforming Venus, working on this would require an ocean and some sort of weathering process, a proposal from 2020 suggests. With enough water, assuming we could access tremendous amounts of the stuff, it might be possible to remove dust from the air and to get the atmospheric carbon dioxide to condense onto the surface. One possible way of making this happen could be to throw immense numbers of icy objects, like comets, into the atmosphere of Venus. How to get that to happen is another question, of course. A 1991 proposal from British scientist Paul Birch has an alternative method: to somehow send out trillions of tons of hydrogen from gas giant planets like Jupiter. The hydrogen, he said, would turn atmospheric carbon dioxide into water with a big side of granite. Venus would also need to be cooled down from the scorching sun using some kind of sunshade, which has the side effect of collecting solar energy for potential human or robotic use.